Now, this is really interesting. This is the surface of standard human bone, and you all know the story about we change our cells out except for our brain cells every 7 years. Every 7 years we're new people because our cells are always changing. This is part of that process. Some of the bone cells go into some of these holes, some of the cells come out of the other holes, and that's how they swap out. Perfectly normal. Now, if you're going to make a deformity, what on earth are you going to take them away for? Well, how's Mother Nature going to do that? What's the point? Again, very, very different with the Starchild. All right, now here we see the piece of maxilla. Now this purple stuff, don't worry about it. That was just when we were taking pictures of it, and we had made a model of it to copy it and do all that. Don't worry about it. But here we see the two teeth, and we see the size of it. 1 inch. And there's more here, so it would have been more than 1 inch. But nonetheless, the roof is flat. The roof of the mouth is flat, indicating a very small tongue or even no tongue at all. So something to talk about is what Rich Dolan was talking about a minute ago, which is the telepathy. Look what we have here. We have a huge brain, we have no sinuses, we have a little neck, and we have a very small mouth. Where do the sinuses fit into this? What are your sinuses good for, do you suppose? I bet every one of you think it has to do with breathing, cleaning the air, warming the air, do something like that. No, there's a layer of bone connecting. It has nothing to do with that. Guess what it's for? It just allows your voice to resonate. If I didn't have sinuses at all, my voice would sound something like this. I would be more like a robot sounding thing because there would be no resonance to my voice. You with me? So, if you've got all of that going against your speaking, no sinuses, maybe no tongue, little bitty neck, huge brain, what does that indicate maybe? Communication with telepathy. I can't say it, I can't swear to it, I can't prove it, but you know, what a combination of effects. Pretty interesting. Now, with all of these physical things that people told me about, physiological differences, and I'm just giving you the highlights, there's a couple of dozen and more, but these are the ones that are important. There were also tests. We did tests, and this was the first one we did was x-rays. Now this is after we had pulled one of the teeth, but it's a better shot than the first x-ray. But what you see is teeth in the top, and teeth in the bottom. Teeth here, ready to come down. When we had that x-ray, the x-ray technician said, oh man, you got teeth down, you got teeth up, that's a kid. 5, 6 years old, that's a kid. So we said, okay, called it the Starchild. Huge mistake, monster mistake, because from that point on, I couldn't at first say, you know, what it was, because if ever I mentioned the word Starchild, scientists would say, oh, well, you've already concluded that it's an alien. We know, we don't want anything to do with an alien. Oh, that means alien, doesn't it? Oh, bad mistake. But by the time I was doing it, it was already out. That was the name, and it's the name today, even though we know now that it's not a child, not a child at all. Later we found out from the wear of the teeth of the human, we can see that her teeth were worn flat like a horse teeth. She died, by the way, between 35 and 45, somewhere in there. She was full up adult. But her teeth were very much ground down because 900 years ago in Mexico, it would have been grinding corn with stone, pestle, and mortar, or however it worked, and you'd get a lot of grit in your food and your teeth would get worn down. It was just a much tougher life in a high desert, very sandy, very gritty area. So what we find with the Starchild is that we have chips in the enamel. You can see those, you can see that. Tough wear on its teeth as well. Kids can't do that. Kids don't have their teeth long enough. Kids can't generate that kind of torque on their grinding to do that. But also we've got crazing. We've got signs of crazing in life. The dark lines that you see there, now there's white ones here, but crazing is chipping of the enamel by chewing very hard things like walnuts or ice, and a lot of it to crack it. And if you do it in life, and you get stains here, so you know this was done during life, so it was generating a lot of torque on its teeth as it was chewing hard things. But these, the white ones, they are post-mortem. They come after death. When you die, your teeth can dry out a little bit and leave those cracks. So you just have to know the difference. So later experts said, nah, it wasn't a kid. Why'd you call it a kid? It's not even close to a kid. And so, because we're idiots. That's why there was no, we're idiots, but there was no instruction manual. There's no guidebook here. We just had to kind of figure it out. And again, remember, I was not a UFO person. I didn't know what I was getting into, and I kind of had to feel along blindly. But I learned. Over time, we all learn, and I learned too. Okay, other X-ray we took. Now, as you see here, the sinuses, the frontal sinuses, this part right here. The eye sockets, frontal sinuses, Starchild completely missing, not the first sign, not a vestige, not anything, and also a very different eye socket, as you see. Very kind of weird look to it. So that was another sign that the guy said, you know, no sinuses like this, man. You just don't see no sign. You can see small, you can see shriveled, but, you know, you just don't see nothing. This was an X-ray tech who had seen a lot of them, so that was pretty interesting. Now, here's his profile view, and it really shows the flatness, the absolute flatness of the rear of the human's head, but it also shows these veins here. And all that is on your brain, you have veins on the top of your brain, and because your bone is so soft when you're young, those veins leave an imprint in the bone that stay with you, you know, obviously as you see forever. Same thing with the Starchild. You can see its convolutions here very clearly, but also you see its veins on its brain, so it wasn't water on the brain. Might have been, you know, they can argue that it was pressure in the brain, but certainly not on the brain. So again, probably not hydrocephaly. Now this is a bottom side view, and you see the opening of the foramen magnums here are the same. Again, the Starchild, if it was having pressure problems in its head of hydrocephaly or the design, the faulty design that, you know, it has, where its neck opening is pushed forward under the dead center part of it so that it's centered up. And I should have said that. It's centered on that skinny little neck in a weird way, like a weird shaped golf ball. It's balanced front and rear and side to side. So it's absolutely designed weirdly, and you would think that that opening would be squeezed out to some degree, but it isn't. It's absolutely the same. It's normal. It's the size that it ought to be. Now, this is a CAT scan. Now, you hopefully know that a CAT scan is just electronic slices through the skull like this, and then you look at the pictures. You start here, and we're going to work our way through, and you see, and these openings indicate that there's no premature closing in any of the sutures. That's what we were looking for. And there was none. It was healthy and normal at the time of death, not a problem. We see more, see those openings right through. But when we got down to this part, to the ears, to the inner ears, the guy that was doing it said, holy moly, what is that? Look at that. The inner ears, man, this thing has inner ears twice as big as what we normally have. And I said, what do you suppose that means? I have no idea. Well, what do you suppose it means? You've got a skinny little neck, you've got a very big head. If the inner ears are a balance mechanism for it, which we assume probably ours is, why would it need that much more balancing power? Well, maybe to hold that big head up on that skinny little neck. Or maybe it comes from another place, different gravity, whatever. Don't know, but it's unusual for sure. Another one of those weird physiological differences. Now, human bone composition. Let's take a look at this. This is what human bone is normally made of, and this is the scanning electron microscope analysis of the human bone. You have carbon, you have oxygen, you have phosphorus, calcium, and all the other ones, sodium, magnesium, aluminum, silicon, sulfur, what is it, chlorine or whatever, calcium. No, that's calcium. Carbon, calcium. Yeah, it's other calcium. Sorry. Anyway, that's it. That's what it looks like. Very standard, very typical. All your bone looks like this. If you were to scan it, it would look basically like this. This is the Starchild's bone scanned. Look at the difference. Look at the carbon, oxygen, phosphorus. Look at the difference right here. You know what that is? Tooth enamel. Tooth enamel. It's much, much harder than human bone. Much harder. 2 to 3 times. We don't even know how much harder. It's just really, really harder. It is not human bone in that sense. It's got the components, but like everything else. It's got eye sockets, got ears, got a brain, but it's all mixed up. It's all jumbled. It's all completely different. But it's jumbled and mixed up and put together perfectly in a new package. Now, you would think that when science saw this, when we made that obvious, you would think science would have jumped on that like a 2-ton tick, would have been all over it. Why? Think how many billions there are to be made if they can pull out whatever is making this happen from the gene code and they can make a serum or a shot or a pill or something to give to people in my generation. I'm on the leading edge of the baby boom, and all to come behind me, and maybe those that are there. Can you imagine the billions to be made if they could figure this out, if they could crack this nut? And they can crack this nut. If they work at it, they can crack that nut. So that's something just there alone. You would think science would jump all over it. But do they? No, they don't want to know about it. You think money runs everything. Money doesn't run everything. Fear runs everything. They are afraid of this. They are afraid of going against the grain because they know they're not supposed to be fooling around with aliens and UFOs or anything to do with it. And so they just pass on billions of dollars, potential billions of dollars.